Professor Dave and Chegg here. We know that compounds with a hydroxyl group are called alcohols, and we must be able to name alcohols under the rules of IUPAC nomenclature. So let's learn how to do this now.
Alcohols can be classified as primary, secondary, or tertiary on the basis of how many carbons are bonded to the carbon that bears the hydroxyl group, and we should be able to identify any alcohol as one of these readily. In terms of nomenclature, alcohols will be treated a bit differently from simple alkanes and haloalkanes, because the presence of the hydroxyl group changes the properties of the molecule so much that we will allow it to change the name of the parent molecule. This is no longer an alkane, but rather an alcohol. Therefore, the suffix will not be -ane, but rather -al, and we will allow the suffix to communicate the presence of the hydroxyl group. Take this molecule for example. We have a 5-carbon molecule with a hydroxyl group and an iodo group. What we must understand is that the hydroxyl group is of a higher priority than alkyl and halogen. We will number the molecule so as to specifically give the hydroxyl group occurring soonest. So here, it doesn't matter that going right to left will give a substituent on carbon 1. We will number left to right because that numbering scheme gives the hydroxyl occurring soonest, and that's what matters most, due to functional group prioritization. In addition, as we said, we do not list this as a substituent, so it's not 2-hydroxy. This modifies the suffix of the molecule. This is 2-pentanol. The "al" tells us it's an alcohol, and the 2 tells us that the hydroxyl is on carbon 2. Then we just list the other substituent first, so that will be 5-iodo-2-pentanol. The parent chain must contain the hydroxyl group, so keep that in mind as molecules get more complex. Let's try one more example. Identifying the longest chain, we see this 8-carbon chain here. This gives us 2 ethyl groups, a methyl group, and the hydroxyl group. Numbering right to left gives the hydroxyl occurring sooner, so let's go ahead and number it that way. Now we list everything in the correct order. We start with 5,6-diethyl, next is 2-methyl, and we wrap up with 4-octanol. 5,6-diethyl, 2-methyl, 4-octanol. We should also look at a particular alcohol, phenol, and its derivatives. When a benzene ring has a hydroxyl group, we call this phenol. If we add substituents, we can continue to refer to the parent molecule as phenol, so this would be meta-methylphenol, since the methyl is in the meta position with respect to the hydroxyl group. If there are 2 or more additional substituents, we can just refer to their positions with numbers, like we are used to. So this is 2,4-dinitrophenol, given that the carbon which bears the hydroxyl is assumed to be carbon 1. Compounds can certainly get more complicated than this, but it will be important to be familiar with simple ones like these, as they will be encountered frequently.
And with that, we have a solid understanding of how to name alcohols and phenols. Professor Dave for Chegg. See you next time.